In this problem, we're trying to figure out if the limit exists, and if it does not exist, then we have to explain why. So looking at this interesting limit, we see that our issue here is going to be these absolute values. And when we see absolute values stuck inside limits, this should tell you that we need to split our limits into the right-hand side and the left-hand side. So we need two limits, in fact. And I'm going to abbreviate right hand by RH and left hand limits. And if we'll recall, absolute value of x is equal to just plain old x if x is bigger than 0, and negative x if x is less than 0. So this is the fact right here that we're going to be using to find the limit of this particular problem. And we're going to start off by looking at, in particular, x minus 3, because that's the stuff that is stuck inside the absolute values. So instead of looking at absolute value of x, we want to look at the absolute value of x minus 3 and what happens there. So let's start off with that. X minus 3 is going to be equal to x minus 3 for every time x minus 3 is bigger than 0. Now this seems straightforward. This is just from our definition of absolute values. Everywhere we saw x, I just put in x minus 3. And I'm going to add into that, that is, and this is where we really need it, if we add 3 to both sides of our equality, we mean x is bigger than 3. So this is coming from the right-hand side. In other words, we're looking at the right-hand limit right here. And we will write that out. The limit as x goes to 3 coming in from the right, which means we need a plus sign in the place we would normally see an exponent. And we're going to start off with our original limit, and then we are going to be able to drop our absolute values because we know that from the right-hand side, this is just going to be x minus 3. At this point, we can actually plug into our equation our number, and let's see what we end up. 2 times 3 plus 3 minus 3, which, since our 3's cancel out, gives us a 6. So there's our answer for our right-hand limit of the absolute value of this particular question. We also need, and I'll put this as an and, we know that absolute value of x minus 3, we'll have to put a negative sign in front of it for x minus 3 less than 0. Again, we're just looking at the second part of how absolute values work. We know we put a negative sign in front of everything. Notice I put the parentheses in there because that negative sign will be distributed whenever our element that we're plugging in ends up being negative. And again, let's do it. That is x is less than 3. So this tells us we are coming from the left-hand limit in this situation. So now we need the limit as x goes to 3 from the left-hand side of 2x plus the absolute value of x minus 3. And left-hand side means we put a negative sign where we'd see an exponent in our where we're going. And let's put a negative x minus 3, and I will just put in that negative sign, and then we will distribute that negative sign. So that is going to give us the limit as x goes to 3 from the left of 2x minus x plus 3. So in this case, when we plug our number in, we're going to get 2 times 3 minus 3 plus 3. Which again is equal to 6. And this is our left-hand limit. In this case, and it does not always work this way, which is why we have to check this out, our right-hand limit and our left-hand limit are the same number. So that tells us that the limit of our function as x goes to 3, and this time we don't have to put any clarifying marks in there, is equal to 6. So there's our solution, nice and easy. Thank you for listening.